let's do one thing. Let's write down the theory fast. After that, I'll explain you the concept. Just write down the theory first. After that, I'll explain the concept to you, right? So that we can have the concept as for the numericals as well. Okay? Just please note it down all the things first. Once do, just let me know. After that, I'll discuss this thing. Okay. You know that India has shattered all the Pakistani batters like the cards. They are like 3 wickets are down, like inside 50. Like they have not completed 50 runs yet, but still 3 wickets down for the Pakistan. India is doing very well.
So India is batting?
India is bowling because Pakistan has opted to bat.
Oh.
Yeah. So inside 50 itself, India has taken done like 3 wickets down for it. Hope so. Hoping for the best. Let's India win. Yeah.
Done so.
Done. Okay, everyone. So now let's just yeah. अच्छा तनिषा करे just let me know once done. Okay.
Done.
Done. ठीक है. Now let's talk about the mass and weight. What mass and weight is basically. So everyone, we know that whatever basically any body inside this universe is made up of atoms particles, right? In the 9th standard first chapter itself, you have heard about particles. That every matter is made up of particles, which is nothing but the atoms, electrons, protons, neutrons, right? So basically, with that body, like let's talk about the differentiating factor between the mass and weight, which is basically, so if you see this thing, the body, which is consist of particles and matter. So whatever that quantity is present inside the body, that is called mass. What it is called, Bacho? Mass. Clear? And the force with which Earth attracts that body towards itself is called weight. Okay, so there is a myth that weight and mass are same. No, weight is different, mass is different. That's why this topic is there, and this is one of the most hot topics in the exam. Like definitely a direct question comes, differentiate between mass and weight. Simple. Like that. Okay, so please make sure to understand this thing properly, right? So basically mass and weight of a body, what is mass and weight of a body are two different things. Mass is the quantity of matter inside the body. If my body is made up of bone, muscles, flesh, and tissues, blood, everything is there inside the human body. So the quantity of matter which is present inside my body will be called as mass. But the earth, the force with which earth is attracting towards the surface, right? That is my weight. Clear? Okay. And mass is a constant quantity. What do you mean by constant? That means wherever you go in the universe, it's always going to be a same. It's always going to same. It's not going to change at all. Clear? Next is weight is not a constant quantity. It depends on the value of G. We know that the value of G changes if you go in the outer space, if you go in the depth of below the earth, right? Earth surface. If you go on the equators, if you go on the pole, both have different values. Yes or no, everyone? In every scenario, the value of G will change, Tanisha and Chakrika.
Yes, sir.
So
Yes, sir.
that's why the weight of a body will change. Okay? The weight of a body will change definitely. Clear?
Yes, sir.
Okay. Now, next thing that is about the mass is basically mass of a body cannot be zero. If there is a body, it will consist some mass and it's not going to be zero. It's going to be anything, but it should not be zero. Clear? Next thing is basically weight of a body can be zero. How? We know this thing when we go outside the atmosphere, the value of G becomes zero. Yes or no?
Yes, sir.
The value of G below the earth would be zero. Yes or no? So in that case, the weight is going to be zero because mass into zero would be nothing but a zero value. So that's why weight of a body can be zero. Okay, all of you? After that, mass is a scalar
Yes, sir.
quantity. Yes, Tanisha, did you say something?
No, sir, I was saying yes.
Okay. Mass is a scalar quantity. That means mass is only going to depend on the magnitude. There is no change in like it will not depend on direction or anything else like that. Okay. And if we talk about just a second, Bachcho, give me a second. Just a second. Are you sure? Okay. Next thing is basically, sorry. Okay. So the next thing is basically weight is a vector quantity. Why? Because weight is nothing but a force. Mass into acceleration is force, na? Right? Mass into G. G is what? Acceleration. So mass into acceleration is nothing but a force. So that's why weight is a type of force. That if force is a vector quantity, so obviously weight is also going to be a vector quantity of the body. Is that clear? So it depends on both magnitude as well as the direction of the motion. Clear?
Yes.
Great.
Yes, sir.
Yes, Tanisha. Anything else there you said? Okay. Next is mass is measured in kilogram. So if we say something like the mass of the body is 60 kg, the weight cannot be in kg. Please make sure if you say 60 kg of weight, that is wrong. That is completely wrong because mass is measured in kilograms and weight is measured in newtons. ठीक है? Clear all of you?
When we measure our weight on a
हाँ,
measuring scale, we call it kilograms.
like didn't get it. What did you say?
When we're measuring our weight on a measuring scale, we call it kilograms.
That's the thing. That's the catching point. Actually, because the normal human brain, because everybody is not aware of the Newton force. Like if suppose that if a person who is not aware, like if basically a child is there who is not aware of what is Newton, what is force, something like that. But that person is aware of the mass. That means 6 kg, 1 kg. Because when we go outside, we say that 1 kg of rice, please give me. Right? Because that person, we know, like since our childhood, we know this thing very frequently. But the force is a different thing. That's why to make it more simple and to make it more acceptable inside, basically in the environment, that's why they said 6 kg, 5 kg, whatever the number written is, your kg. But and it's specifically, it's nothing but your weight. If you're measuring something, because that body is getting attracted towards the surface, na? Ultimately. That's why the value of that specific your scale is getting changed. Yeah.
Yes, but then even on the measuring scale, they
Yeah. Please repeat.
nothing, sir. I got it.
Got it? Yeah.
Yes, sir.
Great. Please do. Okay. So just write down this thing. After that, we'll discuss the derivation portion. Fourth wicket down for Pakistan. Done, Micho? Chakrika, Tanisha?
Yes, sir.
Chakrika, are you there? Now this thing says that like weight of the body on the moon, right? Because if you go outside the atmosphere, you must feel very weightless, right? You must feel very light. You must have seen that the astronaut floats inside in the outer space. Have you seen this thing or not, everyone? Right? Nisha, Chakrika, am I audible to you?
Yes, sir.
Yes, Viju. What happened? Am I audible now?
Yes, sir, you're audible, but your voice was lagging.
अभी भी lag कर रही है.
Yes, sir, like kind of.
Hello, hello. Am I audible now?
Yes,
Yes,
sir.
sir, you're audible now, but it lags in between.
ठीक है. Okay, now let's discuss. We are going to discuss the weight of the body on the moon. Like, suppose that if you basically have a body, right? If you take that body on the moon, what will be the effect of the weight of that body? Like, obviously, on the Earth, suppose that we are having 60 Newton of weight. If I'm saying a body is there and it's basically having 60 Newton of weight, right? So that's why it would be like, but on the moon, obviously, it would be different because we are going in the outer space, right? The body will be in the outer space. So that thing is going to discuss in this chapter, right? In this topic specifically. We are assuming that suppose a body of mass m is there, right? Small m, and the basically weight of the body on the moon is wm, right? So we are assuming that weight of the body on the basically moon is wm, and mass of the moon is capital M, and the mass and the radius of the moon is r. Clear? Just a second.
Yes, sir.
Just give me a second. Just a second. Okay. So, so the weight of the moon, the weight of the body on moon would be nothing but whatever the pull of the moon on that body is basically gmm by r square. Whatever the force with which moon will attract that body is nothing but the force of attraction, nothing but the weight of that body. Yes or no, everyone?
Yes, sir.
Right?
Yes, sir.
So that's why if we see this thing, so W equals W of weight of the body on moon equals to gmm by r square. And now by the facts, by the stats, the numerical value, we know that the value of Earth, mass of Earth is 100 times of the moon. That means the Earth mass is more than 100 times. Okay? And the radius of the Earth is 4 times. By the numerical values, we know this thing. So we are going to assume that the mass of the moon, mass of the Earth would be 100 m because m is moon, 100 m, and 4r will be the radius of Earth because that is r of the moon. Yes or no? So I am going to substitute that value. So I'll get the weight of the body on Earth. So it's going to be 100 upon 100 by 16 into gmm by r square. Got it, all of you?
Yes, sir.
Yes,
Tanisha,
sir.
Chipika, Chikem. Great. Now, now discuss. Now, if we divide this thing, what I will get basically, because I wanted to make a comparison. So obviously, I'll be dividing. So as you can see, gmm by r square will get cancelled on both the sides. So only thing left would be 16 by 100, which is almost equals to 1 by 6th of the value. That means weight of the body on moon is going to be 1 by 6th of the Earth. So if I'm saying that 60 Newton of weight is there on the Earth, so value of weight on the moon would be 10 Newton only. Mass would remain same. Mass is not going to change. But the value with which the Earth or the moon will attract is different. So that's why the weight of the body would be different on both the planets or any other planets. Right? Clear, Chakrika, Tanisha?
Yes.
So please complete this.
Yes,
Complete
sir.
this. Yes. Did you say something, Tanisha?
No, sir.
So this derivation comes in the exam. Show that the weight of the object on the moon is 1 by 6 times of the weight of Earth, weight of the object on Earth. This is a straightforward question for 3 marks. So you have to perform the steps like this with the proper explanation. Why do we assume 100 times? Why do we assume 4 times? Just the thing I've written. You have to show that, like, show the steps like that. Okay. So please complete it.
Sir, can you please scroll?
Done, all of you? Tanisha, Chakrika?
Yes, sir.
चलो
Yes,
ठीक है,
sir.
जल्दी से क्वेश्चन करो, please do this one. एक Chakrika, ठीक है. What about you, Tanisha? Answer.
Yes, I am on.
Okay, Tanisha, got your answer. ठीक है बच्चों, correct. So in this question, you can take 9.8 as well as 10 meter per second square because nothing is mentioned. It's up to you. ठीक है. Please do this question. Okay. Tanisha, 49. It's asking the mass, bache, not the weight.
I texted it wrongly. I'm sorry. I'm doing it again.
Yeah.
It's 5 kg.
ठीक है. Okay, Chakrika. Correct, bache. 5 kg. Very good. Please do this question. Chakrika, what is the value of G on moon? The question is asking that thing as well.
Um,
Yes, Tanisha, correct answer. Correct, Chakrika. Very good, Rishabh. Very good. करेक्ट. चलो एक क्वेश्चन और देता हूँ मैं आप लोगों को. $53 क्वेश्चन. Okay, bachcho. Any answer? Okay, got the answer from Tanisha. ठीक है बच्चे. Big answer. It's 15 kg.
Answer I sent it.
ठीक है, just a second. It's 50.